Hi everyone, Mr. Lansing here, and today we are again going over on multiplicity of zeros, and we are going to determine the factors from zeros and build our function based on the given graph. I want you to take a look closely into the three terms that we'll be teaching you this time. Depending on how the graph behaves at the x-intercepts, we have a cross, a wiggle. So we have a cross, a wiggle, or a bounce. So a cross means there is a single zero at that location of the x-intercept. The graph touches the x-axis and passes the x-axis at one point. And in this case, we have a single zero. When the graph bounces at the x-axis, the exact point where it touches the graph has two zeros. So 0 with multiplicity 2. So meaning there are two zeros existing at that location. If the graph wiggles at a specific value in the x-axis, it means that there are three zeros in that location. To apply that understanding, let's take a look closely into this illustration. So I want you to observe the x-intercepts. We have -3 is 1, -1 is another x-intercept, and 4 is another x-intercept. So let's identify whether it's a cross, a wiggle, or a bounce, because these tells you how many zeros exist in those specific x-intercepts. -3, this is a bounce because it didn't go through the x-axis. It's like a U-turn, so we have two zeros in there. -1 is a cross. It crosses the x-axis, so it's 1 0 in that location. And number 4 seems like a wiggle because it passes through that specific value 4. It stays a bit there, it goes up, it creates a wiggle, so it has 3 zeros here. Therefore, our zeros in this polynomial function, so our zeros this time, based on how the graph behaves in the x-intercept, are the following: -2, -2, -3 and -3, and then we have -1, and then we have 4, 4, and 4. So we can write our zeros like this, like listing from left to right, but we can also write it in the form using the word multiplicity. So we have -3 of multiplicity of 2. It means that -3 comes out 2 times as a 0. -1 of multiplicity of 1, and 4 of multiplicity of 3. So again, when you see multiplicity, it tells you or describes to you how many times a specific zero comes out in that specific function. Go over another example and take a look closely into that specific x-intercepts and what is the behavior of the graph in there. So we have first behavior at -3, it is a cross, 1 0. Number 2, it hits at -1 and it creates a wiggle. So we have 3 zeros in there. And number 3, it is actually bouncing at 2, so we have 2 zeros there. So again, cross is 1, wiggle is 3, bounce is 2. So our zeros this time, based on how the graph behaves at the x-intercepts, are the following: -3, 1 0, it's a cross. -1 comes out 3 times because it's a wiggle, -1, -1, -1. And lastly, 2 comes out 2 times because it is actually a bounce. Our second objective in our topic today is on finding the factors based on the given polynomial, and the third is to solve for the polynomial based on our graph. So we are going to build our polynomial based on how the graph looks like. Okay, let's start with the zeros of this example. So we have start with zeros. Okay, so we have zeros this time based on how it looks like. It has a 0 at -3, another 0 at 2, and another 0 at 5. So based on these zeros, we can actually find the factors of the polynomial. So the polynomial factors are before getting the zeros are the following. So from -3, it should be coming from x plus 3. Your +2 should be coming from x minus 2. And your +5 should be coming from x minus 5. So take note that from zeros, we can set our factors easily. Now we're going to find, because the third question is, what is the polynomial function being graphed here? So we're looking for our polynomial. So this time, what we know about our polynomial is, based on how the graph looks like, it is actually odd, because one endpoint goes up and one endpoint goes down. Aside from odd polynomial, its coefficient must be negative, because from left to right, the graph is going down. But take note, we don't have that value of a, so we are going to find that value of a. So find the value of a, or the leading coefficient. Our hint is it is negative because the graph is going down from left to right. So to find that, we'll create an equation in the form f of x equals, so build up your polynomial, but this time with a missing a, times the factored form x plus 3 times x minus 2 times x minus 5. Okay, so your hint is your a should be a negative value because the graph is going down from left to right. So we're going to use this point here, which is your y-intercept, and plug in this point into our function. So take note, f of x means y, so the y value of this is -15. So -15 equals a times, if x is 0, so 0 plus 3, so 0 plus 3 is 3. If x is 0 again, 0 minus 3 is negative. Oh, so this is 2, -2. And if x is 0, so 0 minus 5 is -5 for the side. So we have -15 equals a times -5 times -2 is +10, and 10 times 3 is +30. And since we are looking for the value of a, we're going to isolate a by dividing both sides by 30. So this is gone because that is equal to 1 this time. So the value of a, therefore, is equal to -1/2, as a reduced fraction from -15/30. So this is our a, which means we are correct with our prediction that the graph is going down because the a value is negative. So if we're going to rewrite our function, then we'll be using that a this time. So f of x is equal to -1/2. Multiply this to all the factors. So x plus 3, we have x minus 2, and x minus 5. This is our polynomial function, and this is the graph of that polynomial function. So take note, we started with finding the zeros, then factors, and then we find the value of a by manipulating our equation. Let's have another example, and hopefully this will be easy for you to do. So our zeros are, in this example, we have zeros of the polynomial are the following: -3, I have 1, and I have 4. Okay, so the factors based on the zeros are the following. From -3, that will be x plus 3. From 1, that will be x minus 1. From 4, that will be x minus 4. Now, third question, we're finding the polynomial. But what do we know about the polynomial? This is odd degree polynomial. We have 3 zeros. It's odd. Then we also know that the graph is going up from left to right, so we are expecting for a positive value of a. So let's create our function. So f of x equals missing a value, factored form, x plus 3, x minus 1, x minus 4. Okay, now let's pick this value here. It's easier. Actually, it's any point from the graph can be used except for the x-intercepts. So, but it's easier once we have one value for x is 0 and then one value for y. It'll be faster. So 8, based on this, plug in this into the function there. 8 equals a times, when x is 0, so 0 plus 3 is 3. 0 minus 1 is negative 1, while 0 minus 4 is negative 4. So 8 equals a. Negative 4 times negative 1 is positive 4 times positive 3 gives you 12. Okay, so divide both sides by 12. By 12, this gives you a equals, we reduced 8 by 12, we can reduce that by 4, 2 over 3. So the value of a is 2/3, and we're correct with our prediction that the value of a is positive as the graph goes up from left to right. Okay, so our function therefore is f of x equals, let's start with the value of a, which is 2/3. Okay, and then times the factored form, x plus 3, x minus 1, x minus 4. And this is your polynomial.